Friends, today we are going to study mean value theorems. There are two mean value theorems in CBSE syllabus of class 12th. One is Rolle's theorem and second is Lagrange's mean value theorem, commonly known as LMVT or just mean value theorem. So Rolle's theorem is also a mean value theorem, but officially when we say mean value theorem, then it is Lagrange's mean value theorem. So today we are going to discuss first mean value theorem, that is Rolle's theorem. Now let us consider the statement of this Rolle's theorem. Let f be any function defined over closed interval a comma b such that first f is continuous in closed interval a comma b, second f is differentiable in open interval a comma b, and third f of a is equal to f of b. These are the conditions of Rolle's theorem. If these conditions are satisfied, it doesn't mean that Rolle's theorem is true for that function. That means we can apply Rolle's theorem on that function. If any one of these three conditions is not satisfied, then we will say Rolle's theorem can't be applied to that function and our problem finishes at that moment. Now if these three conditions are satisfied, then there exist, at least this is a symbol for there exist, this is a symbol for there exist. At least one C where C is any point belonging to open interval a comma b such that f dash C is equal to 0. Now let us apply this theorem on a function y is equal to x square minus 4. Now here we have to apply three conditions of Rolle's theorem. Now these three conditions, that it is continuous, differentiable and f of a is equal to f of b, it is not necessary that you have to apply these three conditions in the same order. You can check any condition in any order, like you can check third condition at first order and then followed by second or first. So what I am doing, I am checking second condition, differentiability. How I am going to check? As we know that differentiability at a point is properly, we find this by limit etc. But here it is on any interval, so we are simply differentiating the function, like f of x is equal to x square minus 4, its derivative is 2x, which is clearly defined over minus 6 to 6. That means there is no point in the interval minus 6 comma 6 which is making this derivative not defined. So clearly it is defined on every point, so it exists. That means f is differentiable over open interval a comma b or interval minus 6 comma 6, and hence it is continuous. Students, this is very very important. We can save our labor to prove a function continuous here, because in calculus there is very very important result that every differentiable function is continuous. Yes, remember this result, that every differentiable function is continuous, though converse may not be true. That means every continuous function may not be differentiable, but every differentiable function must be continuous. Now after that, the remaining third condition, that f of minus 6, which is minus 6 square minus 4, which is 32, and f of 6, which is 6 square minus 4, again 32. So we can see f of minus 6 is equal to f of 6. So hence all the conditions of Rolle's theorem are satisfied, but theorem is verified or not, this we can't say right now. So in order to verify the theorem, now let us see what is f dash c. If we put this equals to 0, that means 2x I'm replacing x with c such that 2c is equal to 0 or c is equal to 0. As 0 belongs to open interval minus 6 comma 6, then we can say we have found one point c which is belonging in open interval minus 6 comma 6, and hence we can say our theorem is verified. Now let us understand the geometrical meaning of Rolle's theorem. Now if we see this diagram, it is graph of a function y is equal to f of x. Now clearly we can see it is, the graph is continuous, that means there is no hole from the interval a to b. Up from a to b, this is continuous, and also f of a, height at a is equal to height at b, so continuous differentiable, and f of a is equal to f of b. Then what does it mean that by Rolle's theorem we can say कि we can find a point c where where derivative is 0. Now as we have discussed in the introduction of derivative that f dash x, that means derivative represent the slope of tangent to the curve, and slope is 0, that means line is parallel to x axis. That means what is c point? C is the point where if I draw the tangent, then that tangent is parallel to x axis. So that is geometrical meaning of Rolle's theorem. That means the question on which we have verified the Rolle's theorem, this question. So this question can be asked in other statement also, that using Rolle's theorem find a point on the curve x square minus 4 in closed interval minus 6 comma 6 where the tangent drawn is parallel to x axis. So this is also a question, kind of a way which can be asked for the same question. So we have to do same steps which we have done earlier. So that's it. That is how we verify the Rolle's theorem. So that's all for today. Take care. Have a nice day. Thank you.